Here is the pre-test for Chapter 6. Alright, so you want to be able to convert from degrees to radians. So whenever you're going from degrees to radians, basically you have to divide by 180, and then you multiply by pi. So you can do this out without a calculator, right? You just reduce. Well, it goes into both 72 and 180. So we could just take 6. Right, so start just reducing this. This goes down by 6, which would be 12. This goes down by 6, which turns into 30. Right, and then you can reduce it down from there. That goes to, switch colors, reduce that down. That is, go by 6 again, so actually 36 would have went into both of these, right? So we get 2, and this will reduce by 6, and we get 5, so we get 2 times pi, so 2 pi fifths. So this answer of 72 degrees is 2 pi fifths radians. So why the 180 is on bottom? Because this is actually 180 degrees, so then your degrees will cancel out, right? And we want to get in terms of radians. So you can put 2 pi fifths. You don't have to put radians, but you can write radians or rads. Okay, if we're going the other way, if we're going from degrees, or sorry, if we're going from radians, which remember, as long as it doesn't have a degree symbol, then it's a radian. It doesn't have to say radians, as long as it doesn't have the degree symbol. And just because there's a pi in it doesn't mean this could be pi 12 degrees, right? But right now it's just radians. So we want to multiply that by 180 over pi, because then the pi's will cancel out, and then we can reduce 12 and 180. We can reduce that by 2 to start, since I can't think off the top of my head, and that's 90. And then 3, well, that's 2, divide this by 3, that's 30, divide by 2, so that's 1, that's 15, so we get 15 degrees. So 15 degrees. So there, see, you don't even need a calculator for it. Okay, so I did these the secants instead of sine, like you've seen on your other quiz, and cosecant, or which is sine. This one's secant, which is cosine. So this relates to cosine. So let's go ahead and actually find cosine of 2 pi over 3, and then we'll just flip the fraction, right? So I did this because you probably have a question like this on the test, right? That's why I did it. So you can just find sine. So you can use the hand, your left hand, to help you find it. All right. 3 and 4. Oh, that's a pretty darn good looking hand. Alright, so if I'm at 2 pi thirds, that's dividing by 3. So if I can use the previous problems I did, right, it's 180 over 3. Right, so that will cancel out, and we get 60, right? So really I'm looking at 60 degrees, and I'm looking at 2 60s. Okay, so really I'm looking at 2 60s. Let me circle that a little better. 2 60s. Alright, so I'm looking at 260, so that's really 120. So I'm looking at 120, but I'm really looking at 60. So here is 0, here is 30, here is 45, here is 60. So then I put that finger down, I have 1 coming out. So that's what's going to go underneath this square root, because the 1 to the left is cosine, cosine's to the left, and that's what really we're after, cosine of 2 pi thirds. And then we're just going to flip that fraction. So we put that 1 underneath, so square root of 1 is 1, and we divide that by 2, so we get 1/2, right? And now we're in the second quadrant, so that's going to be a negative, so this is -1, negative 1/2, and then we go ahead and flip that fraction, so this is equal to -2, so that equals -2. Okay, so we can do the same thing here, except we're going to assign sine of 7 pi 6, so we're dividing by 6, so that's basically 180 divided by 6, which is going to be 30 degrees. So we're actually looking at the 30 degree ones, and we're looking at sine, so we're looking at things to, that's not a very good looking hand, but that's okay. So we're actually going to look at 30 here, so we can put that down, and then we're going to look at the ones to the right, and that's 1 to the right. So we put that underneath the square root, and then divide that by 2, so we get 1/2. So sine of this is 1/2. Okay, but now we got to look at what quadrant we're in. So there's 7/30s. So or you can think if that was a 6 instead of a 7, wouldn't that be 6/6, which is 1 pi? So we're really at 180 is 6/6 pi. So if we do one more, isn't that just one more 30? So we're in the third quadrant. So that's 7 pi 6. So we're in the third quadrant. So that is negative. So I'm down below. So that's negative. And then it's cosecant. So that's just going to be -2. So if I ask you to find secant or cosecant, just find cosine or sine using the left hand method, and then you can go ahead and just flip that fraction. Okay, tangent. Tangent, remember, is y/x. So that means we're looking at our things to the left. Now this is 6 again, so we know that should be a 30°, right? So we're looking at 30°. Ooh. So we're looking right here, and this is 1 and 3, right? So sine is square root of 1, square root of 1/2. So that's sine of this is 1/2. Cosine is, I got 3, so that's √3/2. And then I take sine. Tangent is sine over cosine. So that would be 1/2 over square root 3/2. I flip that fraction, and I get 1/2 times 2/√3, which is just 1/√3. You have to rationalize that, top and bottom, so we get √3/3. Now we look at what quadrant we're in, right? So that means we're going to have, right, this is equal to tan, well, I guess I can write it down here, tan of just a pi 6. Remember there's 6, so it's 2 3s. That's how I always remember it, so then I don't have to do all that work with fractions. But now we have 11 pi 6. Well, if I had 12/6, wouldn't that be 2? So that'd be 2 pi, right? So that means that 2 pi would be over here, but I'm at 11, so this is 11 pi 6. So it's down 30°, right? So, and what's tangent in that fourth quadrant? Well, it's negative, so that means tan, eraser. So that means tan of 11 pi 6 is going to equal -√3/3. Okay, so again, you don't need a calculator for that. Okay, so now we're asked to graph, and again, why I put on these reviews, I put on cosecant, secant, because really when you graph sine or cosine, or when you graph those, you're really just graphing sine or cosine and then inverting it. So really you're going to graph, oh jeez, why did I do that? Sine. Cosecant goes with sine. Okay, so here we're just going to graph sine of that, and sine normally starts at 2 pi, right? And so to find our period, we had to divide that by our b. And our b for this problem, is 2. It's what's being multiplied by x. Now that 2 is on the inside, right? And because that 2 is on the inside, that means we have to factor out and put it on the outside of that parentheses. So we need to divide both of these by 2. And then that 2 becomes on the outside, and then I get x minus pi halves. And that's what finds my d, right? It's always the opposite of that. So my d is pi halves, positive pi halves. Now my c is what I'm being added to it, which is 0. And then my a is what I'm multiplying by the trig function, which is 2. So now I have my a, b, and c. I have my period because I took 2 pi divided by b. So I get pi. Now I can find my interval length by taking that period and dividing that by 4. So there's my interval length, pi 4ths. And so now I can find my start, which for sine or cosecant is always at d. And so that is pi halves. So I want to start over at pi halves. So you can turn this, instead of 0, just make it pi halves. That's fine. And now we're going to add to find our next 1, 2, 3, 4. So we're going to add that interval length, pi 4ths. So we need a common denominator, which is 2 pi over 4. We're going to add our pi 4ths to that. So that means I just have 3 pi 4ths. 3 pi 4ths. And then I add it again, 4 pi fourths. Don't worry about reducing, that's fine. You don't have to reduce. 5 pi fourths. 6 pi fourths. Okay, and then you can do a little test. What's the difference? How far is it from 2 pi fourths to 6 pi fourths? The distance of 4, right? 4 over 4, isn't that 1? So when I get pi, my period length is pi. So that's a little check, right? Okay, so now we can do y values. Okay, y values of sine are 0, 1, negative, or back to 0, negative 1, and then back to 0. Let me fix that one. Okay, so we go ahead and hit those. 0, 1, 0, negative 1, back to 0. Okay, and then what we're going to do is we're going to invert those. Right, my zeros, my original zeros are going to be vertical asymptotes. Okay, and then my, well, if we graph sine, I'll show you what sine looks like, which you should know, right? Probably already do. Sorry. Okay, so this is sine, right? That's normal sine. Now we want to do cosecant, so we're going to make this hill into a valley. And we're going to make this valley over here into a hill, right? I'm just going to invert it. So I'm going to make this into a hill, or a valley, and this valley into a hill. And there's my graph. So that's one period length. That's most times just it does go on forever to the right and forever to the left, repeating this pattern. Okay, so there is your graph. Now we just have to multiply these these y values, this negative 1 and 1, by our a, right, which is 2. So we multiply 1 by 2 and we get 2. We multiply negative 1 by 2 and we get negative 2. And then we would add our c if we need to add our c, right? So we adjust those values. So there's our graph. All right, so it's 0, 2, 0, negative 2, 0, after we multiply by our a. Multiply by a. All right, so there's your graph for that one. Let's go ahead and work on this one now. So secant, so that means I'm graphing really cosine. So here, your a is, well, let's put a up here. A is not 2, right? It's what's being multiplied by secant, which is a negative 3. And then your b is what's being multiplied by x, which is a 1/2. Here our c is what's being added to or subtracted from it. So here is 2. Even though the 2 is not on the right side, it's okay. It's still positive 2, right? I'm taking 2 and then I'm adding 2 basically. This part right here, I'm adding 2. So that's your c, because it's a positive 2. So that's why you're adding it. And then your d is what's being added to x or subtracted from x, but it's always opposite. Nothing's being added to this x or subtracted from this x, or d is 0, which is nice. Because now we can start at 0, right? So we're going to start at 0, and then we're going to add our interval. Okay. Alright, so our normal period for cosine or secant is 2 pi. We're going to divide that by our b. Maybe I should move this over a little bit. Okay, so that's our period. So we take 2 pi and divide it by our b, which is divided by 1/2. And when you divide by 1/2, you times by 2. So 2 pi times 2 is 4 pi. So you're going to go 4 pi long, that's your period. So your interval is going to take that period and divide it by 4, so that's pi. Interval, not p. Okay, so we start at 0, because that's our d, right? And we add pi. So we get pi, we get 2 pi, we get 3 pi, we get 4 pi. What's the distance between this? 4 pi, and that's what our period is. Okay, now y values for cosine are 1, 0, negative 1, 0, back to 1. Okay, and then, so we can go ahead and put those on, that's fine. So then our graph would look something like this, right? That's cosine, right? And then what we have to do is we have to multiply by our a. So I'm just going to take that out. We multiply by our a. So multiply by a. That is becomes a negative 3, 0, positive 3, 0, negative 3. Okay. Then we go ahead and add our C, which is a positive 2. So we're going to add C. So that is a positive 2, positive 2, positive 2, positive 2, and we get negative 1, 2, 5, 2, negative 1. And so those are what's going to be, so the 2 here, our original zeros is now going to be 2. So that means our midline right in the middle here, those zeros are going to be now 2. The ones on the bottom is going to be negative 1. The one in the middle, the one on top is going to be a 5. Okay? And then we're going to invert those after we put our asymptotes in. So our asymptotes are our original zeros. So those points actually don't exist here. Like that point doesn't exist and that point doesn't exist. It's a vertical asymptote, right? Okay, and then our normal hill here is going to turn into a valley. So that's going to go up. Our normal valley right here is going to turn into a hill. Right, it's going to approach the vertical asymptotes. And this one was a hill, or half a hill you could say, and it's going to turn into half a valley. So just like that. And it goes from the point up, right? Because what's going to happen is actually to the right, eventually after another interval, you would have a vertical asymptote, and so this would continue like that. Same thing on this side. You could have a vertical asymptote at the next negative pi, and it would look like that, and then it would just keep on repeating. But we only need one period length, so we can go ahead and just take out, we don't need, oh, I'm just going to stop that there. I guess I'll just leave that, because I don't want to erase everything on it. Okay, so then you can see the distance between 5 and negative 1 is 6, and if you divide that by 2, that would be your A, right? And your A is 3, or the absolute value of your A. Okay. Alright, so there's that one. Okay, so here's tangent. So tangent's a little bit different, right? Our period, it starts at pi, right? So it's a little bit different. Our A here is not 0, because if it's 0, the whole thing, it would just be y equals 0, so it has to be 1. Our B is what's being multiplied by x, which is 1, so I don't need to change anything because it's 1. And then our C is anything being added to this after we take the tangent. Nothing is, so that's nice. And then our D is what's being subtracted from x or added to x before we take the tangent, and that's pi force. And it's always the opposite of the sign in there, so it's positive pi force. So this is the more difficult one, right? So we're going to divide this by our B. So that's divided by 1, so that doesn't change, so that's nice. And then our interval notation is taking that period and divided by 4. So there's our interval. But our start is totally different. So we always start pi at undefined to undefined, right? That's where it goes. And it always starts at undefined at negative pi halves. Right, so negative pi halves. And we're going to add our d to that. So we're going to add pi force. So we need a common denominator. So we get negative pi, 2 pi, excuse me, over 4 plus pi over 4. And so our start is going to be at negative pi force. So we can just change this to negative pi force. Okay, and then we're going to add pi force to that, alright, because that's my interval. So that'd be 0, that'd be pi force, that'd be 2 pi force, and that would be 3 pi force. And then if you take that distance, right, 1 pi force, 2 pi force, 3 pi force, 4 pi force, isn't that a distance of pi? Oops. So that's a distance of pi, right? Okay. So, and now we can go ahead and start our y values. Now our y values are different too. It goes undefined, negative 1, that's a ugly negative 1, 0, 1, undefined. And then cotangent is just backwards. It goes undefined, 1, 0, negative 1, undefined. Okay, so it's undefined at the first and the last. The second is at negative 1. Third is at 0. Fourth is at positive 1, and the next one's undefined. And then it just looks like a cubic going approaching that vertical asymptote. So try to do the best cubic you can do. Don't do a straight line. Okay. All right. So there's that tangent. Okay. Now something that is actually kind of nice. These are not too bad. Okay, so your amplitude is your A, right? It is 2. The hard part is your period, because normally we'd been dealing with B, but remember our period is, so maybe I should just write period instead of P, because you might get that confused with phase shift. Okay, but phase shift is just your D, and vertical shift is just your C. Okay, so the period is normally either for tangent and cotangent it's pi, but so tangent and cotangent is pi, and then for all the rest of them, cosine, sine, secant, cosecant is 2 pi, right? And so look at the equation that it wants you to write. It wants you to write cosine, so that's going to be 2 pi over b. All right, so that's what we normally find it. So 2 pi over b, this is the hard part, equals, well, what's that equal? What's the period of this one they want us to write? It's 4 pi. So now we just want to solve this equation for, b. So basically, maybe I can come up with a formula for you. These are just going to switch, right? So we can say b is equal to the normal period. So normal period divided by new period. That's how you can find your b. So the pi should cancel out. If they don't, that's okay. And then 2 over 4 is 1/2, right? So that's 1/2. So your b is 1/2. So now, and then our d is basically our phase shift, which is pi thirds. But remember, when we write in the equation, it's always going to be, I'll show you. And then our c is -2. All right, so our equation for cosine, or most any of them, y equals, okay, you have your a, then your trig function, cosine, then you have your b, then you have parentheses. You could probably put this in a bracket if you want to, it doesn't really matter. Your b, and then x minus your d. Okay, so it's always doing the opposite. So you think of that negative, it's always the opposite. So what's going to go in the equation is the opposite. And then you can close that bracket, and then you can add c at the end. Okay, so here we have our a, which is 2. We know what trig function we're dealing with, the sine, or cosine, sorry. We can put our b in there. We know that now. That was the hard work. It's 1/2. Parentheses x, and then minus our d, so minus pi thirds. And then close that bracket and add c. Oops, so that'd be -2. So these might seem overwhelming, but really, this is the only work that we have to do. That's the only work that you have to do on these problems. Everything else is given to you. You just have to plug it into the formula, right? And maybe a little bit of work on this one, because it's always opposite, right, of the thing that they give you. Okay, so really, these aren't too bad. So we'll go ahead and do another one real quick. So here, what trig function are we dealing with? We're dealing with sine. So that's y equals a times sine. You can do your bracket if you want. You don't have to do a bracket. You could do something like this. You could just do b parentheses x minus d parentheses plus c. Okay, and that's fine too. So a is good, right? A is our amplitude, right? A amplitude 3. B is the hard work. That's taking the period, the old period, or the standard period, and divided by the new period. And then D is what they give you. They give pi-8ths, but what's going to go in the equation is the opposite of that. Okay, just like when you have an equation, you always take the opposite out, right? And then vertical shift is your C, which is 1. Okay, so the hard work is the period, so we take our traditional period of sine, which is 2 pi, and then we divide that by the period that they give us, and the period that they give us is pi halves. Okay, and when I divide by pi halves, that means I'm multiplying by 2 over pi. So the pi's normally should cancel, so we get b equals 4. Okay, now we can write our equation. So we have y equals our a times sine, our b of b, which is 4, times x minus our d, so that's a negative pi 8, so that's a positive pi 8. Close off that parenthesis, make sure you close off that parenthesis or close off the bracket if you're using the bracket, and then add our c, which is a positive 1. Okay, so b is the hard work, d is always opposite. Okay, now this next one, this is kind of the harder part, right? Because you have to write the equation from a graph. So what you need is you need all 3 of those things, or 4 of those things. You need your A, your B, your C, and your D. Okay, so you need A, you need B, you need C, and you need your D. Okay, so we want to find those, and once we can find them, we can write it just like we did on the last 2 problems, right? So let's go ahead and start with your well, you can start with your A. Okay, let's start with A. So you got to find the midpoint, right? The midline. Where's the middle at between these? So I can go from crest to trough. Okay, and then we find what's the middle of that. Well, the middle of that is right here. Okay, so what you can do is 2 different things. You can find how far is it from the very top to the very bottom, and then just divide that by 2, and that's your A. Okay, or you can find this middle and then find the distance from the middle to the top, or the middle to the bottom, and that's your A. Okay, so 1 to -5, that's a distance of 6, right? So I take that distance of 6, so this would be a distance of 6, and then I divide that by 2, so I get 3, so my A is 3. Okay, so my A is 3. Alright, so once you know that, then you can start working with the other things of finding your C. Okay, and usually you can find C based on kind of what trig function you know. So we'll do that a little bit later. Now let's go ahead and find our B. Okay, our B is where does our graph start and where does it stop repeating itself. So sometimes a lot on these problems it will continue to go on. They will continue to go on in both directions. Okay, so it's not where it starts and where it stops on the graph that it shows you. It is where does it start and where does it stop repeating. Where does it start? Well, pick a point, any point. Where does it start, and then where does it start repeating? Okay, so here we start here, and then so it has the same value right here, right, at 3 pi 4ths, but then it goes down, so I have another value, so it hasn't repeated itself. But I come back here, and now it's repeated itself. So you're trying to find where does it start, and then where does it start again repeating itself. Okay, so where does the graph kind of copy itself? How long does it take that graph to copy itself? That's finding your B. Okay, so to find B, you got to find your period. That's where you find where it starts copying itself. How long does it take to copy itself? So here we go -pi 4ths all the way to 7 pi 4ths. So I can take 7 pi 4ths. So I take my end and I subtract my beginning, which is -pi 4ths. So that would add, so I'd get 8 pi 4ths. So my period is 2 pi. Okay, so that's the period that they give me. Now to find B, I do the same thing, right? Because now it's just like this problem where they give you the period, right? So you found the period. Now you can do that same thing, where you take the period, the normal period, and you divide it by the new period. Is the one we found, right? 2 pi. So that means B is 1, right? B is equal to 1. So now we got our B. Okay, so now we'll go ahead and jump to D, right? Because really, if we're writing our equation, C comes kind of last. Sometimes C comes at the beginning, but we'll do C last, okay? Because now we got to decide what our D is and what our trig function is. Okay, so sometimes sine and cosine look the exact same. If you shift one over, if you shift sine over, right? Because remember, sine of 30 degrees is 1/2. If I shift that over another 30 degrees, right, another pi 6, cosine is also 1/2, right? So you could use sine or cosine for any of these problems of the graphs that you see, that you can rewrite the equations. You can do it in sine or cosine. All right, so dealing with, just pick one. Okay, so if I pick sine, that's fine because this kind of looks like a sine, right? Because sine has kind of 3 points on that midline. That's kind of how I guess you could know. Once you find that midline, the middle there, if there's 3 points on it of your repeating pattern, so find your repeating pattern. How long does it take to repeat itself? And then go ahead and, if there's 3, you can do sine. If there's 2, you can do cosine. It really doesn't matter, like I said. Okay, so now what you can do is you can take this starting point, pick one of your starting points. We'll pick this one. Okay, let's do it red. Okay, and now what's that going to take me? How far do I need to move that to get back on the x-axis? Okay, how far do I need to move that? Well, I need to move that, right? I need to move that a pi force forward. Okay, so I need to move that a pi force forward. Okay, and that's actually what's going to go in my equation. Okay, so I need to move this a pi force forward. Okay, so my d is actually going to be, this is where it gets confusing, is actually negative pi force. Okay, because what's going to go in the equation is pi force. It's pi force is going to go in the equation of pi force. Because I moved this to negative pi force, so I moved it back negative pi force. So what's going to go in the equation is a pi force. So basically, whatever you need to move that point to get to the x-axis is going to be what you put in the equation. So I need to move this a pi force distance. So that's what's going to go in your equation, is how much you need to move it. Okay? So that's going to be what's going to go in my equation. So my d is actually negative pi force. Okay. Now to see, normal sine starts at 0, correct? Okay. It starts right here at 0. How much do I need to move that up to get it to 0? Okay, from where it is right now, how much do I need to get that up to get back to 0? I already shifted it pi force. Now I need to move it up. I'm at -2. I need to move it up 2. Okay, so I'm going to move that up 2. So there's my c, is a positive 2. So that's what I need to get back to 0, because sine starts at 0, right? My y value is 0. All right, so now we can go ahead and write our equation. So y equals our a times by our trig function, and then we can have our b, which is 1, and then we can take our shift over, which is a pi force, so that's positive pi force, because that's how much I have to shift it over, and then my c is +2. Okay, and then if you want to, you could make sure of this, you graph it, right? My b is the same, but my d is negative, so that means I shift over back here, negative pi force. And my period is normal 2 pi, and I divide that by 1, I get 2 pi. Now I divide by 4, I get negative pi force. So then when I add that interval to my start negative pi force, I get pi force. And then it would be, I guess if I was doing the same distance here, I'd probably eliminate that one. And then eliminate, and then probably go here, and then here. If I do, I'm doing correct, like the distance of interval lengths here. All right. If this is one interval, then it needs to be the same size going this way, right? So this would be 3 pi force. This would be 5 pi force. This would be 7 pi force. Okay. And is that what our graphs looks like? Goes from negative pi force to 7 pi force. Yep. And now my y values of sine are normally, right? 0 at the first one. 1, back to 0, down to 1, back to 0, correct? 1, 0, -1. Then we times it by 3, so that would be now a 3. This would still be 0, this would be -3, correct? And then we add 2. So we add 2 here, and we get 5, 2, -1. And so let's check this one. It actually went down, right? So it went down to -5. So what happened there? Well, what happened there was we actually need to subtract 2. So it's a good thing that we checked this, because I went from 3, so it's actually going to be opposite. So I'm going to subtract 2. So whatever you need to move back to 0 is actually going to be the opposite. Okay. So here I had to move up 2, so that's actually going to be the opposite. I'm going to go down 2 instead. Okay, so it's going to be the opposite there. So this is my equation. Because down 2 would be -1, -2, and -5, and that's the y values that I have, right? 1, -2, and -5. Okay, let's go ahead and do another one. Alright, so here, alright, this keeps on going, right? So this kind of looks more like a cosine, but notice that it goes, because there's one cosine right there, right? And now it's like a second cosine. So this is actually 2 period lengths. So we want to do just 1 period length, okay? So we can go from here, that's fine. So we're just going to stop it right here, so we don't care about these other things. Okay, so now we want to find our A. It's by finding the distance. So 4, what's the lowest point? That'd be -1, -2. So that's a distance of 6 divided by 2 is a 3. So our A is 3. Now our period goes from this start to this one, right? So how far is that? -2 pi thirds to 4 pi thirds, where we end. So we take, for our B, we take where we end, 4 pi thirds, where we end the period, not where we end the graph, where we end the period. And we subtract where we start, which is -2 pi thirds. And so we get 6 pi thirds, which is 2 pi. Right, so our B again is 1, right? Because it's to be 2 pi, our normal period, divided by our new period. So our B equals 1. So B equals 1. Okay, and then we can do our D, which is our phase shift, how much it has to shift over. Right, so here we want to get it on that y-axis there. So how much do we need to move this over to the y-axis? Well, we need to move it over 2 pi thirds. So it's actually going to be -2 pi thirds is our D. Okay, so now we can start writing our equation. Y equals, this looks like cosine, right? So we're going to do cosine. And so our A, and then cosine. Our B, which is 1, so 1x. And then plus 2 pi thirds. And now we need our C, right? So here we're going to look, and we multiplied those by 3, right? So normally it goes 1, 0, -1, back to 0, 1. We multiplied that by 3, so that turned into a 3. But how do we get up here to 4, right? So how do we get up here to 4? From 1 to 4, we added 3, right? So we added 3. So C is definitely a lot trickier. But we normally started at 1, and then we moved up to 4, right? We moved up to 4. So was that 1, this was at 0, this was at -1, and then we went up to 4, so that means we needed, or sorry, we multiplied all these by 3, so that's -3. Now how do we get up that to 4? We actually just add 1, right? Here, how do we get to 1? We added 1. How do we get to -2? We added 1. So maybe that's a better way to do it. So maybe that's an easier way. So we're going to add 1. So we're going to add 1 to this. Okay. All right. So let's go ahead and let's go back. Let's go back here to this one. All right. Let's go back here to this one, and let's go ahead and graph this one again. But let's do it in cosine this time. Okay, so let's start it back 11a, and let's go ahead and graph this with cosine, okay? So we can go where we start, and we can go ahead and go how long does it take to repeat ourselves. So that is dealing with our period. So that's taking 7 pi fourths and minusing a minus pi fourths, and we get 8 pi fourths, which is 2 pi. So that means our b equals 1, right? So b equals 1 because that's our period. Okay, and then we can find from trough, or so from crescent to trough, and divide that by 2. So that's 6 divided by 2. So our a equals 3. Okay, and our d is how much we can. What's going to go in the equation is how much we can move over to the x-axis this way, or that was what we did with sine, right? Because sine normally start at 0. Well, on this one, normally cosine, if we're going to do cosine starts up at 1, right? So it's this top value. Well, how far do I have to move this top value over back to the x-axis? So that would be pi force, right? So that would be a distance of pi force going back. So since I'm going back, that'd be a negative pi force going back to the x-axis, right? So that's going to be a positive pi force. That's going to be as my d, okay? And what's going to go in the equation is a negative pi force. Maybe that's sounding confusing. I don't know. So our equation is going to be y equals our a times cosine this time, and then our b, which is 1, and then x, and then minus pi force. So let me think about this. Maybe, so I have to go, basically what you can say, your d is going to be, your d will always be, what is that value, what is that x value of the point that you want to move? Okay, let's say that. I think that might be easier, because then on the last problem, this one that we did sine, right, our d was negative pi force. Wasn't that the x value of this point that we moved? So the point that you want to move to the y-axis, whatever the x value is, that's going to be your d, right? Our d was negative pi force. That's probably a better way to think about it, okay? And then what's going to go in the equation is always the opposite. I think maybe that will help you a little bit better. So whatever the x value is of the point that you're going to move, that's your d, okay? I think that will help. All right, so now we have that part, right? So now really all we need is our c, correct? So here our c is going to be a little bit different, okay? So we need to move this. We already moved it here, so it starts at 1, right? Which normally we do start 1, but the c changed, right? It moved it. So normally at cosine we're at 1, 0, negative 1, 0, 1. But here, just make a marker. I would just do this. Make a marker, just kind of graph normal cosine, which is 1, 0, 1. Okay, and then multiply it by your a, because your a is pretty easy to get. So now this becomes 3, 0. Oh, that's negative 1, negative 3. Right, now how do I get to this 1 up here? Well, I get to that 1 from 3 by subtracting 2. Okay, so I'm gonna subtract 2 from that. So this becomes minus 2. All right, so that becomes minus 2 at the end. So then here's your equation for cosine. So it looks similar to the sine one, right? Except for here, our d is different. Oops, our d was different. Right, that was the problem. Our d was different. Because normal sine, so our x value there was negative pi force, so then what went in the equation was pi force. Well, sine goes 0, 1, 0, negative 1 back to 0. So here we're at 1, 0, negative 1, and then we multiply by our a, so that turned into 3, 0, negative 3. And then how do we get this point in the middle? How do we get that point to the middle up to the top? How do we get that point up there? And so that would be moving it to, we would go from 3 to get down to, well, actually we're at negative 2, right? So you're at negative 2. So we want to take this point right here at 0, and how do we get that down to negative 2? So thinking about it, moving the original rather than moving the new one. So that's why I had to do the opposite. That's why I did negative 2, and I switched it from positive 2 to negative 2, because I was thinking backwards. I was thinking, how do I get the new one back to the original? And so that's why I had to go backwards and do a negative 2. But if you go from your original, how do you go from your original down to your new one? That's where you can just plug that straight in, right? So I had to go down to, for my original 0, I had to go down to get to negative 2. So that's why I can just do the original there. Okay. Let's go ahead and turn that. So here's what cosine, the equation for cosine. So mostly the only thing that changed was just your negative pi halves there, right? That's the only thing that switched. That was your d. Okay. Let's go ahead and do one more. Okay, so originally we wrote this as a cosine, right? So let's go ahead and do it as a sine. Okay, so let's do it as a sine. So your period is still here, right, from the start to the finish, right? That's when it starts repeating itself. Even though this looks like I'm repeating cosine here, that's fine. Or you could start, if I want to do sine from the beginning, right? I might take the middle point, right? So I'd find the middle point by finding the distance between the crest to the trough here, the highest to the lowest, and then divide that by 2, which was 6 divided by 2, which is 3. So we knew A was 3, right? Well, you can take that middle, and you can start with that first middle point, and then how far do you have to move that over? Or sorry, don't think about that. Think about what is the x value of that middle point there. It's negative pi 6, so that's your d, negative pi 6. So that's what we have to move that one over. Okay, and then you can think, okay, how long now does it take to get to that first middle point to that third middle point, right? Because sine does 3 middle points. And so that is a distance. We start our period. We already know this from the previous one, but 11 pi 6th, and we would subtract a negative pi 6th, right? And that would be 12 pi 6th, which is 2 pi, right? So our period is 2 pi, which is the same, so that means our b is 1. And then our c, again, so I would do this rather than probably what I did on the very first one. Just trying to make it better for you, is our start with sine, right? Sine is 0, 1, 0, negative 1, back to 0. Okay, so I'm at this point. How do I get from here, right, to my ending point right there? That first midpoint there. So 1, 0, negative 1, right? Well, first we have to multiply by our a, right? So this turns to 3, 0, and negative 3. Now, how do I go from this first midpoint, right, 0, to this midpoint at 1? Okay, so wouldn't I have to add 1 to this point to move it up to 1, just like this point, right? Just like this point right here moves to 1, right? So that means you would have to add 1, add 1, add 1, and that's how we get the negative 2, 1, and 4. Okay, so then our c is a positive 1. So y equals 3 sine this time. Our b is still 1, and then our d is negative pi 6, because that's the x value of that point that we want to move. And then we always do opposite, so plus pi 6. So see how that kind of looks the same too, but our d is different. Okay, everything else is mostly the same. Okay, there you go.